Hello everybody, I hope you're still doing well. I know we've actually come to a close here pretty quickly in the school year, but I wanted to do a little bit of a review over the Chapter 10 stuff that we've done so far. Just to kind of recap, I know I signed the videos from that other teacher that has her YouTube channel, but I wanted to kind of give you guys my own spin on a couple examples just so you can get the instruction in a couple different ways. So let's go ahead and get started here. As a reminder, 10.1 was really about the formulas for the area of different shapes, such as, you had your traditional ones like triangles, but then you've also got some parallelograms, some trapezoids, and some rhombuses. Remember, we skipped kites, so we're not talking about the areas of kites either. And then section 10.2 we skipped over for the time being. That kind of gets into a little more detail with different shapes. Really cool stuff there though. And then we did 10.3, which was composite figures. So not like a square maybe or a triangle specifically, but maybe you put a square and a triangle together, or maybe you cut a circular hole out of a bigger square, something like that. And then we would find different areas and things that way. So I've got just a few examples here to just get us back on track a little bit for these sections. So the first one I'm going to do is an example pertaining to section 1. So what I'm going to do here is draw a picture. And in this picture, we have that the base of this is going to be, assume it's a parallelogram. So I'll draw the different symbols here. Remember, this means parallel. If you have two sets of parallel sides, that's a parallelogram there. One of the sides here is 6. We do not know, so that would mean this one's 6, but we don't know the length of this side. And remember, the area formula for a parallelogram is actually the base times the height. So depending on the way you look at it, the way I like to look at it is if you take this out here and you make a dotted line outside of the parallelogram, you can make this little triangle shape here. And this is perpendicular now. This length here on this far right side is actually the height. So here's the height. Now in this problem, what we're given is that this is 6 for this base here. But then we're also given that the area is actually going to come out to 7.5. 7.5. So in order to do this, we plug this into the formula. So we have the base, so we have also the area. So we've got 7.5 equals, we'll just plug it into the formula. We've got 6, which is the base, times the height. All right. So now what we'll do is we'll go ahead and divide here. And divide 7.5 by 6. It's going to be a little bit over 1. And then I'll give you guys a couple seconds to do this on your calculator. If you want to do that on your calculator real quick here. And you should get, after you do this, these 6's are going to cancel. H, which is the height, should come out to about 1.25. And if we had units, we would also put units. So like, let's say I put centimeters on here, then, you put that height in centimeters. So that's the first example here. All right. Example 2. We're going to have a trapezoid. Remember, a trapezoid is a shape that has one pair of parallel sides, and then it's got one pair of sides that are not parallel to each other. Okay. The area formula for a trapezoid here is A equals base 1 plus base 2 Remember, the bases are going to be the lengths of the sides that are parallel to each other, divided by 2 times the height. In other words, you're taking the average of the bases here, and then you're multiplying it by the height, or essentially you're taking all this area here and making it into a rectangular type of shape. Okay, so let's see here. Another way you could see this maybe is 1/2 times base 1 plus base 2 times the height, whatever you prefer. Okay. When I said that about the rectangle, basically what this is doing is when you average these bases out, it would be like if you take, so in this example here we have 20 and we have 8. The average of those is going to be 14. So it would basically be like if you extended this 6 units that way, and then if you extended this back down 6 units that way, and then you would actually make a rectangle. So that's essentially what this formula is doing. Now if we plug this stuff in this case, we are going to be looking for h. So we want to find h again, just like we were in the last example. And another thing is, we are going to be given that the area is 280. So then if we plug into the formula here, we're going to have 280 equal to the average of the bases. So let's say 8 is base 1. Let's say 20 is base 2. Divide those, cut them in half, and then we'll multiply by the height, which again, that's what we're solving for. So 8 plus 20 is 28. When you divide that by 2, you get 14. So the next thing we're going to have is 280 equals 14 times h. And then to solve for h, you're just going to divide by 14. Divide by 14. And these will cancel out, and you should get h equals 20. Again, if you had units here, you would just go ahead and put the units on there, whatever those happen to be in the specific problem. Okay. The next example, again, is going to be from section 10.1. We kind of had a lot of different shapes here, so I wanted to get the main examples out of the way for the area of the different types of shapes. So the next one's going to be a rhombus. Okay, so remember a rhombus has all 4 of the same side lengths, but it doesn't have to necessarily be a square. It can be smushed, so one angle pair is a little bit narrower than the other one. So here what we're going to have is this distance from here to here is going to be 8. This distance from here to here is going to be 5. Now also remember, with a rhombus, these diagonals are going to bisect each other. So in this case, what we want to do is we want to find the area, find A. So we're going to find the area of the rhombus. Now, the area formula in general for a rhombus is going to be A equals 1/2 times the length of the first diameter times the length of the second diagonal. Not diameter, should be diagonal there. So the diagonals here are going to be the length, well, half of it's 5, so that means this whole thing's going to be 10. And then we're going to have the length over here, which is going to be, well, the length of this diagonal is 8 plus 8, which is going to come out to 16 at this point. Now a little bit of simplification. 1/2 of 10 is 5. And then if you simplify this, you get 80. Another way to think about this one, and I'll kind of show you this, you notice that this breaks up into four different triangles here, and those four triangles are actually all congruent. So if we recall the area of one triangle, and this is just another way to think about it, the area of one triangle is 1/2 times the base times the height. Okay, well, in this case, the base of this triangle is going to be 8, and then the height is going to be 5. In other words, half of 8 is going to be 4, times 5 is going to be 20. Now, 20 is the area of, let's say, one of these four triangles. Those four triangles are all going to be congruent, so what we can do is multiply this by 4. So area of the whole thing is going to be 4 times the area of one of the triangles, which here is 20, which is going to give 80, which matches up with what we found from the original formula up there. So it's just another way to look at it with the rhombuses. The last example I want to do is going to skip over to section 3, and this one's going to be a composite figure. So composite figures, again, are going to be figures that are made up of different simple figures, but the figure itself is not a simple figure. So let's say that this here is so we're going to have 7. This is going to be 6. This is down here. The whole thing is going to be 12. And then this thing, this little piece over here is going to be 3. So what we want to do is actually break this up into its pieces. Well, what we're going to have here is that this here is a rectangle, and this is a triangle. So if you wanted to kind of erase the lines, and you wanted to just look at what this shape would look like, here's the shape originally, and then we broke it down by adding this little dividing line here to make it into a nice rectangle and a nice right triangle. Okay, so we can find the area of this rectangle pretty easily. Remember, the area of a rectangle is equal to the base times the height, or the length times the width, whatever variables you like to use. And here we're going to have 7 times 6, or 6 times 7, which should come out to 42. So that is the area of this part here. So we've taken care of that part. Now, if this is a rectangle and this part here is 3, then that means this other part here has to be 3. And if this whole bottom is 12, and this part here to make the rectangle is 7 of that 12, then that means that this part over here is 5. So now we have a right triangle. Right triangles are very easy to take the area of. The area of a right triangle is, or a triangle in general, is 1/2 times the base times the height. In this case, we have 1/2 times the base, which is 5, times the height, which is 3. 1/2 times 15. If you do that in your calculator, this is going to come out to 7.5. So that's the area of this part over here. Now we wanted the area of the entire figure, so all you do is you add them together. It's the area of the whole figure is 42 plus 7.5, which is 49.5. So again, this is the area of the rectangle. This again is the area of the triangle. And then the area of the whole thing, you just add those two parts together. Hopefully this helped a little bit, guys. I would like to do a quiz over sections 10.1 and 10.3. next week. So we get another assessment category grade in there. So please be watching out for that. If you have questions, please let me know, and be safe, and I'll see you guys soon. Have a good one.